Okay, good afternoon.
Hindi magiging L and cosine.
Good afternoon po.
Good afternoon po.
Am I heard? Hindi ko lang masyado mailakas yung boses ko.
Property ng ln.
Malab. Naririnig naman?
And
Yes po, ma'am.
Okay, good. Okay, so we have here now another topic. This is members under peer bending. Okay, so I intend to skip the next topic, which is yung torsion. Okay. Three or the compression member, okay, we call it a long column. And for a long column that experience, okay, also pure bending. Okay, so when we design this member, okay, basically it would be the same as this members under pure bending. Okay, so that is the case 3, okay, having a slenderness ratio of greater than 120. Okay, so when we have members under pure bending, this is basically common on members which are subjected to loads perpendicular to the axis of the member. Okay? So, yan po yung kalimitan po natin na nakikita. Okay? So, these are common on what we call beams. Okay? So, when we say beams, okay, so when we say beams, these are long straight members which carry loads perpendicular to their axis. Okay, so this one is our graphical representation of a beam. Okay, so this slender member, long straight member, okay, this is your beam. And notice that you have here on both ends of the beam, you have the supports. Okay, so it supports, it can be a hinge or it can be a roller. Okay, with this supports, okay, the hinge and the roller, there comes the support reactions. Okay, so we all know if there is a hinge, there will be corresponding reactions. Okay, horizontal and vertical. So if this is point A, then a reaction at this point would be AY and also your AX. And then if you have a roller, there would only be a normal force on it. And they say you have there your CY if this is point C. Okay? So you call this the support reactions. Okay? So this can be seen on the supports that are onto your beams. Okay? So before we design a member under pure bending, necessary that we know first the classification of the beam. Okay? So how are beams classified? Okay? It is through the way they are supported. Okay? So you look at our sample here. Okay? So supports are on both ends. So we have here a hinge and then we have here a roller. Okay? So we call that type of beam. Okay? So we call it a simple beam. Okay? So you call it a simple beam or simply supported beam. Again, if it's a simple beam, this is yung beam po natin, and then supports are on both ends. So you have there a hinge, and there you have here a roller. Okay, so both are on different ends. Okay, so that would be a simple or a simply supported beam. The second type, we call that an overhanging. Okay, overhanging beam naman po, okay, it is when, okay, this time, the supports both wala po sa magkabilang dulo. Okay? So, you have here both supports on both ends. This time, okay, wala parehas. Okay? And another one, it can be the one is at the end, and then the other end, yun po yung wala. Okay? So, these are called overhanging beam. Okay? Again, when both ends are on both ends, we call it simple. Okay? When one or both are not on those ends, we call it overhanging. And then the third type, okay, you call it cantilever. Okay, when you say cantilever, one end is fixed,
Newton, think of
and then the other end is a free end. Okay, so the fixed end can be on the right, okay, and then the free end would be on the left. Okay, so it is also considered as a cantilever beam. Okay, so these three, okay, these are what we call statically determinate beams. Again, we call these three statically determinate beams, meaning you can find the values of the reactions on supports through your equations of equilibrium. Okay, so for example, you have this, okay, this is under a simple beam. Okay, so you'll see the reactions AY, AX, and CY. Okay, so how can you obtain the values of these reactions? You simply make use of the equations of equilibrium. What are those equations of equilibrium? Anyone? Yes, Carl. Carl?
Ito po yung mga sumunod na forces, the effects and the
okay lang.
Okay.
Ito naman yan eh.
Okay. So, equations of equilibrium include summation forces X is equal to 0, summation forces Y is equal to 0, and summation of moments equal to 0. Okay? So, you call this your equations of equilibrium. And these are the ones that you will be using in order for you to solve for this reaction. AX, AY, CY. Okay? So, yan lang po yung gagamitin. Okay? That is why we call these three statically determinate beams. Okay? So, how do we design these members? Okay? So, a member under pure bending, of course, that would experience bending of the member. Okay? So, here, okay, is our beam. Originally, it is horizontal. Okay? As you have seen here, it is the axis, original axis of the beam. After you put in there the load, okay, you put here the load. This is the force you applied, okay, to the beam. Look at this part now. There is corresponding deflection or bending. Okay? Ito po siya ngayon. This is the final form. So initially it's horizontal, then this is the final state. There is bending. Okay? Or there is deflection of the beam. Okay? So on the deflection, you would see this. Okay? So taking a closer look at the fiber of the beam, okay, you come up with this. When you say bending, okay, when you say bending, so the material will bend this way o kaya po kapag ganito. Concave upward or concave downward. Okay? So it's a happy face, then this one is a lonely face. Okay? So when you say bending, that is tension on one side, okay, and compression on the other side. Okay? So in this case, nandito po yung compression and tension dito sa outer layer. Okay? Here naman po, this is tension, and then below po would be yung compression. Okay? So, when you say bending, it's tension on one side, okay, and compression on the other side. That would be the effect on the material. Okay? That is why for bending, we make use also of symbol sigma. Okay? Just the same as that of tension and compression. Okay? Just to differentiate, okay, we use subscript F, okay, in this case. So we use sigma sub F for the flexural stress. Okay, now for the flexural stress, this is your bending stress. Okay, so this is your induced stress, and the flexural stress is simply equal to MC over I. Okay, just to recall. Okay, flexural stress equal to MC over I. So where can you obtain the value of M, the C, and the value of I? So in design, this is what you will do. You simply equate, okay, the design stress to the induced stress of the material. Okay, so this is the design stress sigma D equal to the flexural. Okay, look that we make use here of sigma since the induced stress is in form of sigma. So, wag po natin paglalahukin. Okay? So, design stress equal to the induced stress. So, the induced stress is MC over I. And the design stress, this can be written as sigma U divided by factor of safety, or pwede rin po sigma Y divided by factor of safety equal to the induced stress MC over I. Okay? So the first equation here, okay, sigma U over Fs equal to MC over I. This will be used if the design is based on the ultimate. Okay, if it's based on the ultimate strength, then you use this equation. But if the design calls for a design based on the yield, then you will be using sigma Y over factor of safety. Okay? So, ganun pa rin po, okay? Basis of design. And if basis of design is not mentioned, okay, again, you would see the type of material. Okay, if it's ductile, you use yield. Okay, if it's brittle, you use the ultimate strength as the basis of design. Okay, so sigma U and sigma Y, these are taken from our design tables. Okay, same with Fs, the factor of safety, which is taken from table 1.1. Okay, so we focus now on this induced stress. Okay, M, C, and I. So how can we obtain the values of each? Okay, the M, the C, the value of I. Okay, so when we deal with beams, okay, necessary that we know two things. Okay, the first one, you determine the beam loading. Okay, that would be the beam loading. And then the second one, you have to know also the beam cross section. Okay, beam loading will pertain to the forces, okay, being handled by your beam. Say for example, on our classroom, okay, if you see the ceiling ng mga classrooms natin, you would see there dalawa pong beams. Okay, so yung beams po na iyon, okay, so yun po is has a certain purpose why it is located doon sa itaas. Okay, so these beams, these are not designs of your ceiling. Okay, they simply support the succeeding floors. Okay, so you have to compute what are those forces, okay, from the succeeding floors, and that contributes to your beam loading. Okay, so from the beam loading, okay, that is where you will obtain the maximum moment. Okay, so dun po natin makukuha from the beam loading yung pong M natin na gagamitin dito. This is the maximum moment. Okay, and then the other one is the beam cross section. Okay, so what would be the beam cross section? Okay, so for the beam cross section, this is where you'll obtain the value of C and also the value of I. Okay, moment of inertia. Okay, again, so for this equation, MC over I, M is to be taken from the beam loading, and C and I is from the beam cross section. Okay, so let us start first with finding yung M maximum. Okay, so that is from the beam loading. Okay, so M maximum, this is maximum moment. Okay, this can be obtained, okay, from the shear and moment diagram. Okay, so you will be drawing your shear and moment diagram. Okay, so when we say shear and moment diagram, you would have here a graphical representation. Okay, so it's a graphical representation of the shear and the moment all throughout the length of your beam. Okay, halimbawa, you have your beam on the ceiling po ng atin na classroom. Okay, so given that length, you can evaluate, okay, which is the weakest part. Okay, that is through this diagram. Okay, so you will draw the diagram for the shear, you will draw the diagram for the moment. Okay, and then identify which is the weakest part. Okay, if failure would occur, okay, it would likely to occur doon po sa may pinakamataas na moment. Okay, doon po sa may maximum moment. Okay, so through this diagram, okay, through this graphical representation, you can determine where is the failure. Okay, and we will be using that failure now, okay, to design the member. Okay, so nakabase po doon sa failure na yon yung atin na magiging dimensions. Okay, so this shear and moment diagram, this can be done using two methods. One is analytical, and then the other one is the semi-graphical method. Okay, analytical and semi-graphical. When we say analytical method, what you will do first is to derive equations. Okay, you will derive equations for shear and derive equations for moment. Okay, and then you will be setting limits and substitute these limits to the equation. So therefore, you could have a numerical value, okay, for the stress and the value of the moment, okay, the shear and the moment. So that would give us now, okay, yung pong values which are to be plotted to create the diagram. Okay? So, yun po yung ginagawa on the analytical method. Okay? On the semi-graphical method, this one is a shortcut method. And almost everybody prefer to use the semi-graphical kasi nga po, it's a shortcut method. Okay? So, how does it become a shortcut method? Okay? So, analytical, what makes it laborious is the derivation of the equations. Okay? And yun po yung eliminate, okay, here at the semi-graphical method. Okay? So, you eliminate those equations of shear, those equations for moment. Okay? So, what you do only on the semi-graphical method is that you simply have a continued sum, okay, of the forces and continued sum of the areas. Okay? So, kumaga, this is simply using plus and minus and using the sign convention, pataas pa, baba yung ating mga forces. Okay? So, that is the semi-graphical method. Continued sum of forces and continued sum of areas. Okay? So, this is simply mainly summation, okay, or continued sum. So, although mabilis po siyang gamitin, okay, easily na gamitin, okay, but then, this is more risky than that of the analytical method, okay? Why is this more risky? Kasi nga, it's a continued sum. So, therefore, if we have a wrong value, okay, or wrong answer initially, up to the last end, okay, wala na po tayong tatamaan, okay? So, mali na po lahat. Wrong na po lahat. Okay? So, yun po yung sa semi-graphical. But whether, or kahit po alin, okay, within these two, okay, if you use analytical or you use semi-graphical, the output must be the same. Okay? So, you must yield at the same shear and moment diagram. Okay? And most specifically, you should arrive at the same M maximum. Okay? So, for example, you use analytical. Okay? And you obtain a maximum moment of 10 kiph. Okay? Dapat, if you will be using semi-graphical on your solution, okay, you would yield exactly the same value. Okay? Kaya nga, sabi natin, you could have their two methods, but then the output must be the same. Okay? So, this is where you will obtain your maximum moment. Again, Paano po? You have to create your own shear and moment diagram. Okay? Now, take a look at table 82, everyone.
Yes, so class.
Okay? Table 82, page 4 to 5. Okay, everyone. Okay? So, what is in table 82? Pages 4 to 5. Okay? So, ito po yung atin na table 82. Yan. So, title is Moments and Reflections in Beat. Okay? So, we have here two columns. The first column refers to a concentrated load. Okay? So, this refers to a concentrated load. Whereas the other one naman is for a uniform load or a rectangular load. Alin po yung concentrated load? Halimbawa po, ito po yung atin na beam. Okay? You have here a hinge and then you have here a roller. Okay? Yan. And then, say the load is applied midway. Right? This is the force equal to 10 kips. Right? 10 kips. And then, applied, we have the length of the beam. Say this is 2 inches. And this is another 2 inches. Okay? So, here is the illustration. Okay? So, this one is under concentrated load. So, I will be using row 1. Okay? So, try to check if this is, if alin yung katulad natin dito. Okay? On table 82. Okay? So, looking at the first figure, these two are different. Why? It is fixed to this end. Okay? And none of this is fixed. Okay? So, X na po ito. You go to the next one. Okay, you go to the next one. Okay, ito po yun. Okay, so you have here the load applied F. Exactly at the center. Okay, and then we have here the entire length. Okay, so you divide the length into 2. L over 2. The other one is L over 2 din po. Okay, so L over 2, L over 2. Okay? So, ito po yung katulad po natin dito. Okay? Ito yung katulad niya. Okay? Kasi you have here po the supports which serves as the reaction. Okay? So, ito po yung reaction natin at A, reaction at point C. Okay? So, iyon din po ito. Okay? So, iyon din po ito. Yan. You have here reactions are okay, and then this is the other one. Okay? So, ito po yung katulad. So, pag nakita po tayo ng katulad, okay, the same as the treated in table 82, what you need to see is, you look for the equation of M maximum. Okay? M maximum equal to FL over 4. Okay? So, yun po yung ikakopy natin. Okay? So, M max is equal to FL over 4. Okay? So, this is valid only, okay, doon po sa sample po natin. Okay? Now, you look again at table 82. Okay? So, kukunin po natin would be this equation. M max is equal to FL over 4. Okay? So, considering that, okay, let us take the case for this one. Okay? So, what would be our answer? Okay? So, you have here M max is equal to FL over 4. Okay? Substituting, this is 10 kips. Okay? Ano po yung length nito? 2 and 2. So, we have there 4 inches. Okay? Divided by 4. So, you can cancel out this 2. Okay? So, we have our answer and maximum is equal to 10 kip. And then you have your inch. Okay? So, ano po yung value ng atin na M maximum. Okay? So, yan po ay magagamit lang natin. Okay? If, okay, yung po ating
number 2, number 3, number 4, number 5,
Yan,
number
okay?
6.
So, you have this po, okay, for the value of M.
Hindi na
Okay?
wala na
Pupuntahan mo na po is table 82, okay? If wala po sa table 82, then you go back to knowing your shear and
Alin
moment
po
diagram.
dito ang
Okay?
inilagay natin
So,
sa
kinuha
number
naman po natin yung equation, okay? Coming from,
Oh, Mr. Royland.
okay? So, we have here FL divided by 4, okay? Wait lang po,
Oh, anong
may tatawag
derivative
lang.
ng Royland?
Okay, so let me continue, okay? So, we can have, okay, table 82 only, okay? You can simply copy the equation there for the value of M maximum, okay? Only when it is the same as the given on the problem, okay? If not, okay, there's no other way but to create the shear and moment diagram to obtain the maximum moment, okay? But then, if you copied it from the table, okay, just include, okay, the reference table and the page number, okay? So, this will lessen your time, okay, in obtaining the maximum moment, okay? So, that would be table 80, okay? So, that would be the value of M. Now, let us obtain the value of C and I, okay? So, where can we obtain the values of C and I? It will come from the beam cross section, okay? So, on your table 81, okay, everybody, yan. Okay, so this is table 81. Properties of sections, okay? So this 4, okay, above, this refers to your regular cross sections, okay? So you call this regular cross sections, okay? So they are called regular cross sections since these are regular polygons, okay? Whereas the second type, we call this the economic sections, okay? So this includes an I-beam. This is inverted T. Okay, so these are considered economic sections. Okay, economic since the construction material, okay, that would be used to produce this is minimized. Okay, so this one comes from rectangular cross-section. Then, inalis po natin ito. Okay? So, it makes now the material of construction minimal. Okay? As compared to that of a rectangular cross-section. Okay? So, economic section, and then this is regular cross-section. Okay? So, what we need to do here, okay, is you obtain the value of C and I. Again, when you say I, this is called your moment of inertia. Okay, this is the moment of inertia. Whereas yung C, we call C as the perpendicular distance. Okay, perpendicular distance from neutral axis to outermost fiber. Okay, yan. So C is called the perpendicular distance from the neutral axis to the outermost fiber. So let us find now values of C and I both for regular and economic sections. Okay, so we start with this one. Okay, so this one is rectangular. Okay, so it's a rectangular cross section. So let us have first yung I, the moment of inertia. So you would see here, okay, the equation for I, BH cubed over 12. Okay, so that is the moment of inertia. Now, we find value of C. So how do you find value of C? Let us go back to its description. Perpendicular distance from NA. NA stands for the neutral axis, okay, to the outermost fiber. So we need to look first for the neutral axis. Okay, the neutral axis, this is simply a line, okay, or an axis that will divide your cross section in such a way that when it is divided, the two parts would be equal. Okay, they would be equal in weight. Okay, say for example, you have a rectangular cross section. Okay, we all know for a rectangular cross section, okay, the neutral axis is at the center. Okay, since the two, okay, this is symmetrical. Okay, so this is your neutral axis. Okay, and then this is the datum line. We set po, okay, the bottom as the datum line. So we label that DL. Okay, so if we are asked, where is the neutral axis in a rectangular cross section? Okay, it is at a distance. Okay, so if this is B and the height is H, your neutral axis is at a distance H over 2. Okay, so it is at a distance H over 2. Okay, from the datum line. Okay? And then after knowing this distance, this is H over 2, you look also for the other distance. Neutral axis up to the topmost. Okay, member. And this distance is also H over 2. The same po iyon since this is symmetrical. Okay? So you have to compare the two distances. Okay? From the neutral axis to the top and the neutral axis to the bottom. Okay, you have to know these distances. Okay, and once you know these distances, you have to pick or you have to choose whichever is higher. Okay, whichever is higher, then that would be the value of C. Okay, so in this case, your C is simply equal to H over 2. Okay, height, okay, of the rectangle divided by 2. Okay, so this is the value of C and the value of I for a rectangular cross section. Okay, now, so let us have the circular one. Okay, for a circular cross section, your I is equal to pi d to the fourth over 64. Okay? Pi d to the fourth over 64. This is the diameter. Okay? So the entire ano po is the diameter. Okay? So what about the value of C? Okay, so how do you again obtain the value of C? So you set first the datum line. Okay, so this is the datum line, the bottom. Okay, and then here, okay, is your neutral axis. Okay, at what distance is it from the datum line? What distance? Jared?
Radius po.
Yes, Hans.
Kung hindi mo yan,
Radius po.
Okay, that would be equal to the radius. So the radius would be d over 2. Okay, so this is d over 2. Let us now measure from the neutral axis up to the top. Okay, what is this dimension or what is this distance?
D over 2 din po.
Correct. This is also d over 2. Since again, this is symmetrical. Okay, so you have there the same distances. So in this case, okay, again, you compare the two distances, whichever is higher, then that would be used as your value of C. Okay, so C here would be d over 2. Okay, let us take the case of non-symmetrical member. Okay, say for example, we have po triangular. Okay, say we have triangular. Okay, say this dimension is B, and then the height would be H. Okay, this is B and then this is H. Okay, so we set the datum line.
Okay, ngayon, gagawin natin yung 1.
Say we set the datum line. So yung ilalim, okay, would be set as the datum line or the reference line. Question. So where is the neutral axis? Where is the neutral axis in relation to this datum line? Total height is H.
Okay,
Where is the neutral
particular?
axis? Hello?
Anong sagot doon?
Yes, John? John.
1/3 of H po.
Okay,
From?
2x.
From the datum line po.
Okay, correct. Okay. So your neutral axis that passes through the centroid. Okay. So this is your neutral axis. Okay. And what is its distance? From the datum line, that is H over 3. Okay. The height divided by 3. So that is the dimension below the neutral axis up to the bottom. Okay. Up to the topmost neutral axis up to the topmost, what would be the distance? Yes, Jared.
2/3 height, 2/3 H.
Okay, correct. This is 2/3 H. Okay. So you have the two distances already. Okay. 2/3 H, and then this one is H over 3. So which will be used as the value of C?
Kadali lang noon.
Which is to be used as the value of C? Yes, Ken?
Yung 2H over 3 po, ma'am.
Correct. That would be 2/3 of H as the value of C. Okay. For the value of I, if you have a triangular cross section, it's simply equal to BH cube, okay, divided by 36. Okay, so this is the value for I. BH cube over 36. So this is for a regular cross section. This one naman po, you call this tubular, meaning this is hollow outside. Okay, it's hollow inside. Okay, so inside diameter, small letter D, and then big diameter for big letter D for the outside diameter. Okay, so this is how you obtain the value of C and I for a regular cross section. Okay, So let us now take the case of an economic section. Okay, so this is the economic section. Okay, so these are the samples. Okay, so let us now have, okay, a sample. Okay, wherein it is not included here. So we will try a different cross section so that you would know how do you obtain values of C and I. Okay, say for example, we take yung pong atin na T cross section. Okay, so for example, we make use of a T cross section.
O, 6 na taon na. And then, hindi ko ini-encourage kayo. Kaya ngayon pa lang, nag-aaral na. Gagawa na ng effort.
Okay, so say let us have the dimensions. Let us put dimensions. Okay, say this is 1 inch. This is 3 inches. Okay, this is 1 inch. This is 3 inches. Wait lang. Hanap po ako ng mas na space.
Okay? So, let's go to number 3. Medyo dalawa ka ng functions. O, alin dito, try muna natin. Alin dito ang i-derivative natin.
Okay, I'll be using this
Dapat
space.
makita natin dyan ang kanyang derivative of Mr. Brent.
Okay, let us take the case of an economic
yung 2
section.
minus sin 2x. So, try natin ha.
Okay, say let us have a T cross section.
Is the commercial position. So, if you let the u is 2 minus sin 2x,
Yan,
its
okay?
derivative
And then let us
u
put
is
dimensions.
ang 2, 0 na. Pwede hindi na isulat. Ang sin 2x, ang derivative
Say this is
ay
1 inch.
2
This is
cos
3
sin
inches.
2x.
Okay,
Then
so
copy
1
negative
inch, 3 inches.
1 doon.
Okay, for
Ang
this naman
problema,
po,
nandyan pa sa given.
okay, say this is 2
Initially,
inches,
sabihin mo, wala.
1, and then 2.
Sabi, wala.
Okay, all
Originally nga, wala.
units in
But we can
inches.
divide both
Okay,
sides by
2,
negative
1,
2.
and then you have the
Negative 1/2 du.
okay.
Cosine 2x.
So these are the dimensions of your economic
Kaya
section.
nasa sa given.
So first, how do we obtain values of C and I if we have an economic section? Okay, so you have A is neutral axis. Hello, naririnig?
Ayun.
Ma'am, nawawala po yung audio niyo po.
Wait lang po.
Magiging cosine 2x dx. So, papalitan mo ng identity. Cosine, yung 1 over second, di ba reciprocal yun? Gagawin yung nasa numerator cosine 2x kasama na ng dx, so which is now your du. So initially, hindi mo mapapansin na oy, nandun ang du, pero pag ginamitan mo ng identities na naman, reciprocal, ay nandun yan du niya. Kaya if you rewrite ang 1 over second ay papalitan mo ng cosine 2x dx.
Okay. So,
Then yung cosine 2x dx.
okay, so you have to locate first the neutral axis. Again, our aim here is to obtain the value of C and I. Okay? So how is it done if you are given an economic section? Okay? So our sample here is a T cross section. Okay? So you have here a T cross section with dimensions 2, 1, 2. So this is a total of 5 inches. And then here, a height of 4 inches. Okay? So the first thing that you should do is to locate first the neutral axis. Okay? So where is the neutral axis for this T cross-section? Okay? Earlier on the rectangular cross-section, we can easily locate the neutral axis since it is symmetrical. Okay? So we know that it is at the half of the height of the rectangle. Okay? The same manner, doon po sa atin na triangular cross-section, we know it is at 1/3 of the height from the datum line. Okay? Because it passes through the centroid. But on these economic sections, we are not certain as to where is the neutral axis. Okay? So, andun po ba siya sa half ng height natin? The total height is 4 inches. Is it at 2 inches? Yes or no?
Hindi pwedeng i-split dahil may
Is it at 2 inches? Yes or no?
No.
No.
No po.
Okay, no. So, hindi po siya nandun sa half since mas matimbang po yung taas kasi you have this part here. Okay, this is not symmetrical. So, we are sure that the neutral axis is not at the center. Okay, so we have to find now where is the neutral axis. So, how will you do it? Okay, so again, you have to set a datum line. Okay? So, you set the datum line. Okay? So, say for example, we set po yung ilalim as our datum line. So, we label it as DN. Okay? And then, where is our neutral axis? Okay? So, we are to sketch here our neutral axis. So, wala po siya doon sa middle. Okay? So, perhaps, it would be higher. Okay? It would be higher than half of the total height. Okay? So, lagay po natin dito. Okay? Say, for example, this is your neutral axis. Okay? So, you label it NA, neutral axis. So, more than half is our assumption. Okay? So, half of this is 2 inches. Okay? So, this is more than half. Okay? So, its distance, we have to know its distance. Okay? So, what is its distance? Okay? From the datum line, it would be at a distance y bar. Okay? So, it's a distance y bar from the datum line. Okay? So, that is how you locate the neutral axis. So, you use the equation A total y bar is equal to summation of A y. Okay, so this is our equation. And you are to find the value of y bar for you to locate NA. So, when we say, where is the neutral axis of this T cross-section? It is at a distance y bar from the bottom, or it is at a distance y bar from the datum line. Okay, so determine the value of y bar. Okay, so first you have to divide your economic sections, okay, into regular cross sections. Okay, so in this case you can divide it into 2. Okay, so this is 1 and then this is yung part 2. Okay, so this is part 1 and this is part 2, or we call it section 1, section 2. Okay, so when you have here summation of AY, okay, kung gaano po kadami parts, okay, ganun din po karami yung set ng AY. Okay, since you have here 2 parts, so you have there A1, Y1, plus for this, you have area 2, Y2. Okay, so we have here 2 parts, that is why we have here 2 sets. Area 1, Y1, area 2, Y2. Okay, then divide this by area total. When you say area total, then that would be area 1 plus area 2. That would give us the value of y bar. Again, what is y bar? That is the distance of your neutral axis from the bottom, from your datum line. Okay, so let us now solve.
Ngayon lang na
What is the value for your area 1? You look at your area 1. Okay? It is in the form of a rectangle. And area for rectangle is base times height. What is the value of the base?
Method nyo,
Luigi.
makakancel ang gitna.
5 inches po.
Okay, correct. What about the height?
Negative side.
1 inch po.
Okay, correct. So, base times height. So, this is 5 inches. And then height is 1 inch. Okay, 1 inch. Yan. So, 5 inches. And then you have here 1 inch. And then what about this Y1? Okay, what is Y1? Okay, so what is Y1? So Y1, okay, consider only your section 1 or your part 1, okay? So this is your section 1. It has its own neutral axis, okay? So nandun po sa gitna niya, okay? It is in the middle of your section 1, okay? So this is your NA1. Okay, so we call it NA1, meaning that's the neutral axis of part 1 only. Fit load.
Next is
Subjected to a concentrated load of 2,000 pounds
for
at a
cosine
point
naman.
3 feet from one of the
Integral
supports.
cosine x
Determine the
of
maximum
0
fiber stress.
pi over
When you say maximum fiber stress,
So,
this is
dahil
also
naka-format
your
na ito ng
flexural
basic
stress.
formula ng
Okay?
trigo, ang
Okay,
integral
so
ng
what you
cosine
would do is to
positive sine
draw, okay?
sine
Yun
x.
po ang atin na setup, okay? So you have there a simply supported beam.
Ano naman
We
ang
have the
decrease ng
dimensions
pi over
given,
6?
okay? And then also the force applied, okay? So pakilagay po natin, okay, yung
sine 30 degrees. So,
diagram po natin on this simply supported beam. Sige po.
1/2
Antay ko muna po kayo.
O, ganyan din ba ang binigay ng calculator?
O, ano pong itsura ng inyong drawing dyan, okay? So, let us have first a simply supported beam, okay? So, this is the simply supported beam, okay? Meaning, yung ating supports are on both ends. So, I have here a hinge, the roller on the other side, okay? So, this is your simply supported beam. Okay? Now, a concentrated load of 2,000 pounds is applied. Okay? So, the beam has a total length of 12 inches. But then, from the supports, 3 feet. Okay? Sorry, this is 12 feet pala. Okay? This is yung force, which is equal to 2,000 pounds. Okay? So, ari po ay 3 feet. So, if this is 3 feet, this is 12. Ano po distance ito kabila?
Ang dx ay
Hello?
130.
Ano pong distance yung kabila?
9.
Retain and
Okay.
cosine u.
So, that
9
would
feet
be,
po, ma'am.
And the formula
okay, it would be equal to 9 feet. Okay? So, this is our illustration, okay, pertaining to the sample problem, okay? And another one is, pwede rin kung ganito, okay? You can have another illustration. Okay, so the same, you have the supports on both ends, and then this time, okay, and then this time, this is your force equal to 2,000 pounds, located 3 feet, okay, this is 9 feet, a total of 12, okay. So you can have your drawing like this one, o kaya po ay ito. Because it is not clearly stated that, okay, the concentrated load is applied 3 feet from one of the supports, okay. It does not mention whether it's the left or the right, okay. That is why both are accepted, okay, both are accepted. Okay? Now, this is the beam loading. So, you call
Okay,
this
so-
your beam
So
loading.
then, substitute nyo yung 5
Okay,
over
this is the
6
beam
sa
loading.
x,
I'll
magiging
be
3 pi over
drawing
6,
naman po the beam cross-section.
and that is
Ano pong sabi
pi
doon?
over
2 inches
Ano nga, pi
wide
over
by 4 inches high. Okay? So, ilagay po natin.
Joseph, sum
Ayan. Say, this is the cross-section
90
of the
degrees.
beam.
Ayan ay 3 times
Okay,
30
so this one is 2
pi over
inches.
6. Ayan, 90.
And then this one is 4 inches. Okay? So, we are asked to determine the maximum fiber stress. So, that would be your flexural stress equal to MC over I. Okay? Equal to MC over I. Now, let us have first, okay, yun pong M natin, yung C at saka yung I. From the given cross-section here, you can have the value of C. C is simply H over 2. So 4 inches divided by 2, C yields 2 inches.
Yan. Second naman, ang
Okay, so yung meron na po tayong C. What about po the value of I? This is rectangular. So what is our equation for I? B H cubed over 12. Okay? B, ano po yung B natin?
Dahil ang derivative ni second x ay second tangent.
2 inch.
Okay, so B is 2 inches. Yung H is 4 inches
From 0 to
cubed
5 over
divided
3.
by 12. So what would be the value of I?
Substitute second 60, second 5 over 3 minus second 0.
10.66667 po.
Calculator ang second.
Again?
Nagamit tayo ng identity.
10.66667 po.
Ang second
Okay,
x ay equivalent sa 1
10.667
over cosine.
inches raised to the
Therefore, ang second 5
Okay.
over 3
Okay? So, yan po
ay
yung
1
value ng
over
I.
cosine 5 over
So, ano na lang po yung kulang? Yun pong M. Okay? The maximum moment, dito naman po natin kukunin sa beam loading. Okay? Dito po kukunin. So, ano po yung sabi ko kanina? To obtain the maximum moment, okay, ang uunahin po natin, tingnan natin yung table 82 kung may katulad. Okay? Pag may katulad po, okay, so, you look for the equation for maximum moment. Okay? If not, okay, there's no other way but to solve using the shear and moment equation. Okay? So, let us take a look first, okay, at table 82. Okay? So, this is table 82. Okay? So, you look at our sample problem. Okay? So, you have here a simple beam and then you have here the load applied. Okay? Not at the center but along the length of the beam. Okay? So, let us see if there is one similar to the given. Okay? So, you look at the concentrated, the first column. Okay? So, this is the first column for concentrated load. So, dito po tayo titingin. Okay? So, it is the same on yung page 5. Okay? You look at the first row on page 5. Okay? It would be the same as this. So, you have here the okay, so you have here the reactions on the supports. Hello? These are the reactions on the supports. Okay? And then here is the load you apply. Okay? This is the load you apply, the force. Okay? Now, so how is this similar with our sample? Okay? So this is our sample. Okay? Ito po iyon. Okay? Even though that this load, okay, this distance is smaller than the other one, okay, as stated here on our table 82, okay, this can still be used. Okay, so you look now for the equation, okay, of the maximum moment. So you look for the equation and you see here the equation for the M maximum. Okay? Since this is similar to the given problem, so we adopt this equation. Okay? M max is equal to FAB over L. Okay? A are the distances, okay, of your force coming from both ends, okay, coming from the supports, okay. So F from the left would have a distance A, and F from the right would have a distance B. And the total length would comprise yung L po natin, okay. So let us apply and adopt this equation, okay, on our sample problem.
High school yan, ha?
Okay, so we have here now, okay, for a moment, okay, M maximum is equal to FAB divided by L. Okay, this is taken from table 82 page 5. Okay, and then you substitute the value. Force is 2,000 pounds. A is the distance from the left, so that is 3 feet.
Dinesimal, o tama bang point?
Okay, and B would be distance of the force from the right, that would be 9 feet. Okay, divided by the total length, 12 feet. So what would be the answer? What is M max?
Second square.
Yes, Prince.
What's the integral?
4,500 pound foods.
Diba the answer?
4,500. Okay, that is 4,000. Tama po ba?
Upper by over 4 minus
4,500 pound foot. Okay, kindly check the others. They yield the same.
Tama ba no 1?
Yes, ma'am.
Yes po, ma'am.
Yes, ma'am.
So this is M maximum. Okay, 4,500 pound foot. Okay, even if your illustration, okay, or even if your illustration is like this, okay, that 3 feet, okay, would be from this end, from the right side, okay, you will yield the same answer. Okay, it will simply be 2,000 times 9 feet, and then this would be your 3 feet. Okay, so it's a matter of having the values of A and B. Okay, but then the final answer would simply be the same. Okay, so this is what you need, okay, C, I, and M, for you to solve for the flexural stress. So you have to substitute all of them. Okay, so we arrive here at 4,500 pound foot. You simply convert this to inches. 1 foot is 12 inches. Then you have there C is 2 inches divided by I. 10.667 inches raised to the fourth. So what is now your answer? Okay, so what would be the resulting unit? You cancel out yung feet, inches squared, and this is inches to the fourth, so there is remaining 2. Okay, so you have here your answer would be pounds per square inch, or this is PSI. Okay, what is the value?
Pi over 4 ay square root of 2.
10,125 po.
Okay, correct. 10,125 PSI. And if you wish to convert that to KSI, divide by 1,000. 10.125 KSI. So this would be our answer. Again, what is this? This is your flexural stress. Okay? This is the flexural stress. This is your induced stress. Okay, question?
Anong identity yun?
Wala po. Okay, so tomorrow,
Identity.
tama ba? We'll have our meeting tomorrow, right? Okay, so tomorrow we'll continue this one. Okay, we will be adding on the sample problem the design part. Okay, so what we have now is simply we solve for the induced stress. Okay, so tomorrow we will be incorporating yung design. Okay, any question?
reciprocal
So
nito.
try to save po the copy, okay, for this solved problem of ours. Same thing with the sample of the economic sections that we initially solved, okay? Ito, okay? So try to save a copy of this po, okay? This economic section, okay? We will be using this value, I total, okay? And C for the economic sections tomorrow, okay? So, do you have any question?
So,
None?
sasama dyan ha.
None po, ma'am.
Okay. Kung wala na po, I'll stop the presentation now, okay? And then I'll end the meet. Yes, Prince? Hello?
I just want to take a picture of the last solution.
Again?
I just want to take a picture of the last solution.
Power na ano, ay dito pa lamang, kung tinatype yan, ay nabibigito na agad ang final na
Which one?
mas maganda.
Lectural?
Yes po.
Pero yan class ang detail ng sunod-sunod ng pagsisimula. Sa examination naman, eh,
Okay, so you may take a screenshot. Wait.
Sa substitute, at aring pahuling are ay pwedeng
Done po, salamat.
Okay.
1, 2, 3 ay
Any other?
last string are
Wala na po. Okay, so I'll stop the presentation and then I'll end the meet now. Okay, Rio, kindly take in charge for our attendance today. Okay, thank you. Yes, Jeter.
Okay?
Ma'am, may question po pala ako, ma'am. Gawa ng ano po, ma'am. Habang nag-discuss po kayo kanina is ano po, sinusundan ko po yung pagsusulat niyo po dun, ma'am, sa mga PDF, ma'am. Di ba po, ano, ma'am? Una po is dun sa module, ma'am. Tapos nung lumipat po tayo dun
Medyo,
sa...
medyo hindi kita maintindihan, anak. Pakiulit mo.
Ma'am, hello po. Clear na
Yes
po,
po.
ma'am.
Okay, okay.
Ma'am, bali kanina po, ma'am, is di ba po, nagkaklase po tayo. And nag-notes po kayo sa mga, ano po, sa libro, dun po sa PDF ko. Eh, sinasabayan ko po, ma'am, ng pag-notes din po sa libro ko dito. Eh, nung lumipat po bigla dun sa, ano, ma'am, dun sa mga, ano, napanotes din po ako dun sa, ano, dun sa lagayan po ng
As I have said, okay, as I have said, no notes on our design tables, okay?
Kung ano po kayo, ma'am, pwede kong gawin, ma'am? Pwede ko po,
I'll try to see first, okay? Let me check it first during our face-to-face meet po, okay?
Okay, so thank
yes
you
po,
very
ma'am. Sige po, ma'am.
Okay.
Salamat po.
Any other? Wala na po. Okay, I'll end the meet now since it's time already, okay? Jared, you are raising your hand.
Same question lang po no kay Jeter.
Okay.
Napasulat lang po ako sa Jeter.
Okay. Rio, you have our attendance already?
Ma'am, wait lang po.
Naku po, Panginoon ko, Diyos ko. Oy!
Okay na po, ma'am.
Okay, thank you. I'll see you tomorrow. Okay, bye.
Salamat ka po, ma'am.